For miscellaneous topics we will discuss. First one is disk management. Simple your revision kind of thing like low level formatting or physical formatting, dividing a disk into sectors that the disk controller can read and write. Each sector can hold header information plus data plus error correction code. Error correction code, I hope you have studied in your DLD, Digital Logic Design and CO subject, if you have studied, and then usually 512 bytes of data can be selectable. To use a disk to hold files, the operating system still needs to record its own data structures on the disk. Partition the disk into one or more groups of cylinders. Please mute yourself. Uh, okay. Partition the disk into one or more groups of cylinders is treated as a logical disk. Logical formatting or making a file system. To increase efficiency, most file systems group block into clusters. Disk input output done in blocks and file input output done in clusters. Boot block initializes system. The bootstrap is stored in ROM, read-only memory. Bootstrap loader program stored in boot block of boot partition. Methods such as sector sparing used to handle bad blocks. Sector sparing means we spare some sectors in case of any block is not working properly. We can use those spare sectors. Next topic is swap space management. Swap space, you have heard this word before when we were discussing virtual memory. Swap space management is another low-level task of the operating system. Virtual memory uses disk space as an extension of main memory. Since access is much slower than memory access, using swap space significantly decreases system performance. The main goal for the design and implementation of swap space is to provide the best throughput for the virtual memory system. Swap space use Solaris, for example, suggests setting swap space equal to the amount by which virtual memory exceeds pageable physical memory. In the past, Linux has suggested setting swap space to double the amount of physical memory. Today, that limitation is gone and most Linux systems use considerable less swap space. Some operating systems, including Linux, allow the use of multiple swap space, including both files and dedicated swap partitions. We are discussing about that how virtual memory use swap spaces and how are the different ways swap space is managed by the operating system. Swap space location, where it is located, a swap space can reside in one of the two places. First one is it can be carved out of the normal file system. That is, you can just carve out from a standard file system, or it can be separate disk partition. So now here is the one homework for you. You have to read an example of swap space management in the book you will get in the Galvin book. And the last topic of your syllabus that we will discuss is disk reliability. How we will increase the disk reliability? Suppose your laptop hard disk crashed. Suppose your laptop hard disk is crashed, then your all data is vanished. Then what? From where you will get that data? Tell me. Tell me. What is the reliability of your hard disk? If you are storing your data only one place and your laptop is suppose burned or your hard disk vanished or someone has stolen your laptop, then from where you will get that data? Is it possible to get that data back?
No, sir. If I did not store that data at any other place, then there is no
Exactly. If you have not like copy that data somewhere else in another hard disk or in pen drive or somewhere, then you cannot get that data back because someone has stolen your laptop or it is destroyed by someone. Then you will not get that data back. So the how you will increase the reliability by duplicating the data. By duplicating the data means you can copy that data, that is your critical data, somewhere else also, right? Got it? So
Yes,
this
sir.
is what how we increase the disk reliability. Having a large number of disks in the system offers the potential for improving the reliability of data storage because redundant information can be stored on multiple disks. We can store one information in two or three places. If one disk is down, we can use another disk to increase the reliability. Thus, failure of one disk does not lead to the loss of data. A variety of disk organization techniques, collectively called redundant arrays of independent disks, are commonly used to address the performance and reliability issue. Improvement of reliability via redundancy. Redundancy means you are copying your data on multiple places. So the simplest, but it is expensive in nature because you have to use another hard disk to copy your data. So approach to introducing redundancy is to duplicate every disk. This technique is called mirroring. With mirroring, a logical disk consists of two physical disks, and every write is carried out on the both disks. The result is called a mirrored volume. If one of the disks in the volume fails, the data can be read from the other. Data will be lost only if the second disk fails before the first failed disk is replaced. Now here is an homework for you. There are seven levels of RAID. RAID is what? Redundant array of independent disks. You have to just go through it that which level uh, solve the reliability problem at which extent. And another last topic is input output management. It is not that much important, but you have to just read it that what are the input output devices, what are the input output subsystem and input output buffering. Okay, so this is the homework. You have to just read it from the book for your personal knowledge. Not that much important for the examination perspective. But it will be good if you just read it. Okay, so we are done with your